Alright, so let's start our talk about characters. So, we haven't talked too much about them, because they're fairly simple, right? They're just single letters. Except they're more than that. Because remember, on the back end, they're numbers. Every character combination is represented by a bunch of binary bits. So, the English ones, they range from basically from 65, from the number 65 to 128. You can look up an ASCII table to find out, right, yes. So that's what I'm talking about, ASCII, to see what the terms are. And I'll link it to a video that explains basically how, what I thought was a great explanation about how everything is encoded on the internet and, well, in text everywhere these days. But a character, remember, is just kind of numbers. So I can totally add one over here, and well, that won't print anything because I didn't print anything out. This will print out B. I can also subtract 7 from this, so 7 characters before A is a capital Z. Okay, what was 6 characters before A? A bracket. So, now, so these are just numbers. So I can put in a number over here, 65, and character C, and I'll get capital A. 97 for lowercase a. Cool stuff there. Alright, what about, but you gotta be careful with characters, and if you're doing addition with them, you gotta be careful where you're doing it. So, if I did, C plus 2 over here, you expect it to be, C, but instead you're gonna get 99. Now, why is this? Well, because we're doing a character plus an integer, and that gets converted. So our character gets converted to an integer. So we get 97 plus 2, which gives us 99. If we want it to be displayed as a character, we can cast it, except we have to cast the whole thing, because that just simply says treat the next thing as a character. This says treat the whole thing as a character. Alright, so what's cool about this is that we didn't get to see this before. For char C is equal to let's put this capital A, C is less than Z, less than or equal to Z, C plus plus. Once this means start at character A, which is 65, keep going, increment that to 66, then 67, then 68, then 69, right? And then we want to keep going to whatever value Z is. So system.out.println, let's print out C. So we print out all the values from A to Z, uppercase and lowercase. And if you want to see the numeric values associated with that, we can do, we can kind of make that a table. So let's go ahead and we'll cast C as an int over here, right? So here C is going to be treated as an integer. Then we're going to glue that together to a tab, and then we'll glue that together, concatenate it with the letter itself. So it's from 65. So the value. So we start at 65 and we keep adding that, and then because we're interpreting it, since it's a character and we're printing a character, it displayed it as this letter value. Okay, how high does this go anyway? Well, kind of ridiculously high. Whoa, those are some interesting symbols, right? So it's not just the English symbols, right? You get all sorts of different glyphs and symbols that you might need that can be represented here. That's pretty cool to know. All right. And what's cool is that you can check if you can say if you can use if statements with these. So we can say if C is so if we've got some character C is equal to, let's go with R. We can use this. If C is, we can use this if statement by asking if C is greater than or equal to A and C is less than or equal to Z. So in other words, if this is between, you know, A and Z, capital A and capital Z, we can say, hey, capital, right? That's a capital letter. If I put an A here, we're not going to get anything. But if I put a capital A there, boom. All right. And of course, we can always check for equality, which you'll need to do. Bam. Okay. So obviously it works the same way for strings, right? String S is equal to A if S equals, this is actually painful for me to write because there's so many things wrong with this. First off, you can't double equals compare this, you know, a string to a character. Right, so obviously we'll have to do that. And obviously that's going to work 100% of the time, all the time, with absolutely no sarcasm in my voice whatsoever. Okay, so now, and obviously these two things are different, so we're not going to print out anything. But now, let's use that substring operation. So let's look at these documentation that come from the substring operation. Whoops. It's okay, I can highlight it over here. Whoops. Returns a string that is a substring of the string. The substring begins as specified begin index and extends to end index -1. The length of the string becomes end index begin index. So hamburger dot substring 4 to 8 returns urge, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. So it doesn't include the last. So 4, 5, 6, 7, but doesn't include 8. So 1 through 5 returns mile. So let's just go ahead and return A. That's in the index 2 and index 3. Run. It's not running. What's going on there? All right? In fact, let's print out to make sure that they're the same, right? System.out.println. Making sure that this is, in fact, a capital A. It is. So why is my double equal working over here? Well, this gets into the fact that I've been hinting about in the previous videos, that this doesn't actually store an A, and this doesn't actually store blame. Instead, what this is doing is that objects store the memory location. So objects like strings and scanners, they don't actually store these things in there. Wait, what do you mean? Well, so we've got this int x, right? Int x says we've got this that we're creating an integer. Integers are 32 bits. They're always 32 bits. So the computer knows that it needs to allocate 32 bits of memory whenever I do this. 32 bits of storage somewhere on my computer to store that 5. Okay? Same thing with the double. Doubles, except, are 3.2. I'm sorry, let's say 3.2. That is 64 bits of space taken up by that. Always 64, doesn't matter what it is. Strings, on the other hand, well, they can be something as short as a single character, or they can be the entire complete works of William Shakespeare. When I declare a string S like this, it doesn't know if I'm going to, at S equal to A over here. Okay, it doesn't know what to set that much space aside, or if it doesn't know if I'm going to go to the Project Gutenberg, go here, search for good old Bill, complete works of William Shakespeare, plain text UTF-8, Control A, Control C. It's gonna hate me for doing this, I'm sure. And it doesn't know if I'm just gonna copy paste this into there. Oh, I think I've made my compiler cry. Well, that's okay. We're still recording, so that's fine. Right? It doesn't know, but end of the day, it just doesn't know how much space I'm going to be just dumping into here. Yeah, we'll go ahead and close it and put it out of its misery. So I ended up having to delete that because it just didn't like being having large amounts of text paste into it. So okay, if we can't use double equals, what do we use here? We'll go into the why much later with the whole memory location thing. That's what we don't. Right now, I don't want to use too much. But know that if it's an object, right? In other words, if the type starts with a capital letter, which is what objects should always start with. So we've got some string is equal to AB, A. And again, our string, so string S, S2. So S1 and S2, let's call them. Is equal to and we found out that if we did this, if string, right, S1 equals S2 dot substring 0, 1, same, they in fact would not be the same. So how can I make sure that these two things are the same? Well, for objects, which is again anything that starts with a capital letter, we want to use a method to do that. So instead, what you want to do to compare strings is to use the dot equals method. And this will compare the actual values. What do I mean by the actual values? Well, I mean the actual letters that we're actually comparing. When we do double equals, we compare what is stored inside here. And as I've been saying, Java doesn't actually store for objects. It doesn't actually store the values in here. What it does is store the memory locations of these values. So double equals compares the memory locations. The value is actually stored inside that. Again, we'll get into that in more detail. But for right now, all you have to remember is that if it's objects like this, use dot equals.